So let's see the one by one how we can find out the correlation. So firstly, I want to import some library useful like import numpy, snp, panda, matplotlib, and some sklearn basically import cbon warnings, and one more library basically from sklearn linear regression. And one more thing, like if you want to use the matplotlib. So this is the basic library which I want to load. Now I want to click to execute, and now I want to take the next code and I want to load the data like from google.colab import files. So whenever you click to there, so it will demand for upload the salary. So I want to click to choose files and go back to there. So I want to load this salary dataset, salary dataset.csv. Now you can see it will load it successfully. I want to fetch out the data and I want to load the data like load data set. So df salary data. So salary data into this manner. And now I can use to visualize the data. You can see the year of experience and the salary. Now I want to find out the relationship between the year of experience and the salary. So firstly, I want to find out the dependent variable. So dependent variable like x is df year of salary, and independent variable is y salary. So we have the two variable. First one is a year of experience and second one is a, so year of experience it is a independent, and because the salaries depend on the year of experience I want to check out. So dependent and independent. And now I want to apply so into the linear regression. I want to fit the data. And how we can fit the data, like I can choose any variable, linear regression, and dot fit, and I want to pass x and the y. So you can see I have successfully fit this data into the linear regression. And now if you want to find out some scores of the data, like model score like r squared 2. So we can perform and we can print the score and the coefficient also. Now I want to show first the coefficient and the r square basically and the data intercept. So the score, the accuracy, 90% accuracy of my model. So we are saying like the 90% strong correlation between the year of experience and the salary. And this is the intercept of the line where it will be used. Now I want to predict the value. So, so predicting value means I can choose any variable and the regression and then predict it. So if you want to predict the value, you can see there are so many values. So the predictions are there. But there is no requirement for the prediction. So I want to comment it. Now I want to visualize the data. Like PLT. Firstly, I want to set some data visualization chart size like 10 by 10. 10 by 10 it is okay, but I want to use 10 by 6. And the scattered and the predicted is y. Let's see first what the output is going there. You can see this is the strong correlation from my data and this is the slope line basically. One is a scattered, second one is a plot. But I want to use the legends. So I want to supply label actual and this is the fitted line. And once you have fitted the line, then I can use the X label, Y label and the legends. And the title also I want to use like PLT dot title, like year of experience versus salary. So now I want to show this data into this chart. Very effective, very nice. Now you can see it is the actual data and this is the fitted line and the salary. So year of experience. So we can say that the when the experience is going to high, so the salary is also going to high. So that is the strong correlation between the data. And this is the code basically from the scratch. Firstly, I fetch out the data, some coefficients, and to fit it the result and to visualize the data. So now this time I want to use the polynomial. Like polynomial regression. So suddenly in polynomial, similar I want to use some library. So those basically I have not used. So I want to use only the from, sklearn, pre-processing and the polynomial. And again, I want to define some data set like the X label and the Y label. So through this one, like dependent and the independent variable. And now I want to set the polynomial basically. Polynomial features. So if I want to pass the polynomial features, so the thing is that if you want to pass the degree 2 by default, and it will transform the data. And what is the data transform? If you want to print the x poly, so you can use this. You can see the fit transform this data, like year of experience and the salary, like 1.2, 1.2, and also the correlation like 1.44, 1. So it will be uh, transform those data is maximum like 1, 1, so nearby to this one. Labeling, you can also say that. And after that I fit the data. And if also I want to print the, so the linear regression, so there are some coefficients are there, and the prediction is also there. So you can see after transforming this data, you can see the accuracy of my model. But when I pass the degree, because 2 is okay, so now you can see this is the effective thing basically. And now correlation, it is also high, the correlation accuracy 96%. You can say the strong correlation, but I want to uh, hide this thing. There is no need basically. So the data correlations. And if I want to use and want to visualize this data into the useful plotting, like PLT, so the plotting is look like the same as compared to the above. So I just want to copy it. But now the question is that I want to use this Y prediction, and the fitted line I want to change to the polynomial. Remember one thing, like whenever you print this data, so it is okay, like linear and the polynomial, the degree is 3. But I have copied the data from this one. So because now I want to visualize the data. So if you want to copy this data and go back to there, and I want to change the polynomial, and the basically year of experience, polynomial regression. So now I want to discuss Very nice, very effective. You can see this is the polynomial basically into the data. So it is a best fitted line. So this is the actual data and this is the polynomial data. So now I want to discuss the logistic regression. So the logistic regression is useful to test the Boolean and the logistic. So logistic regression, it is a supervised machine learning algorithm widely used for the binary classification like the 0 and the 1, like true and the false, yes and no, such as identifying whether an email is spam or not, and diagnosing disease by assessing the presence of the absence of a specific condition. So the patient test, these particular symptoms are available, yes and no. So on that situation, the logistic libraries and the algorithm is much effective. So it is a supervised machine learning concept. So I want to again import some packages. Import, not the import directly, like from and sklearn and the logistics. And I have already used the polynomial, the pre-processing, the polynomial. And again the similar, the dependent and the independent variable like x and the y is it is needed. So my question is that I want to basically demonstrate. So let's salary. So if the salary greater than 50,000, so is 1, otherwise 0. So the y equal df. So the salary basically greater than 50,000. So I want to show like it is yes, true, and it is false, like 0 and 1. And I want to convert if like there is any changes so into the integer. Now I want to fit. So inside this logistic regression, again I want to find out the logistic regression coefficient and the intercept and the predicted. So and the accuracy of the my model is also. So accuracy is not the matter basically right now, because the similar accuracy score also the x and the y. This one. So I want to supply the x and the y for the accuracy score. Okay, very nice. You can see this is the binary representation, the 1 and the 0. So it is 1. So after this, I want to visualize this data. So again, I want to use the above code for the data visualization, this one. and I want to pass the thing basically. The threshold is it is okay, so the predicted is it is okay, but not the predicted directly. So the uh, logistic regression it is there, but the probability, and the linear regression it is also used for the probability, useful for binary and check the probability. So data probability into the air, like 0 and the 1. So I want to use the probability functions. So the regression predict, not the normal predict, probability of the x. So before showing this chart, I want to comment this, and I want to show the predictions, the probability is there. So you can see the data probability is there, but my intention I want to print only the second one index, 0 and the 1, this one value, because the so now I want to pass colon comma 1. Okay, so no need to pass there, actually to pass there. Very nice. Now you can see I have successfully passed and the first index. Now I'm going to visualize this data. So the Y prediction basically. And now if you want to visualize this data, very nice. Now you can see. So those experience is I think 2.2 something. So the salary is less than 50,000, and those experience is greater than 2.2%. So the salary is greater to 50,000. But I want to change some heading like the logistic regression. And this is also the logistic. Now it is such and probability of the salary. So the probability of this one. So very nice and a very, very effective example of this logistic regression. The logistic regression is useful and it is a part of the supervised machine learning. The probability of the salary greater than the 50,000 salary. So you can see. And the legends also I want to use. You can see the legends. So it's such a very effective